Okay, let's look at a demonstration problem on a company to see whether or not they should make or buy a particular item. So this particular company, we've got TechSmith. They manufacture an optical switch that is used in its final product. Tech Systems incurred the following manufacturing costs when it produced 68,000 units last year. So we've got the total product cost. TechSmith does not yet know how many switches it will need this year. However, another company has offered to sell them the switch for $13.50 per unit. If they buy the switch from an outside supplier, the manufacturing facilities that will be idle cannot be used for any other purpose, and none of the fixed costs are avoidable. So all of these manufacturing fixed costs are unavoidable. We are going to incur them whether or not we manufacture the product in-house. So let's go ahead and set up what if we make the switches and what happens if we buy the switches. Okay, now we know if we're going to buy them that our total cost is going to be $13.50 per. So I'm going to go ahead, I'm going to set this up just slightly differently since we don't need a lot of room for that make or buy. So I'm just going to make this one our make. And we'll put buy right here. The reason is because they didn't give these numbers to us in per unit. So we're going to have to do some division and divide out all these costs by the 68,000 units. And if we do that, then we'll get our per unit costs. So it looks like for our direct materials, if we take 612 divided by 68,000, it's going to cost us $9 to make in direct materials. And it will cost us $2 in direct labor, 136,000 divided by the 68,000. And then $1 in variable manufacturing overhead, 68,000 divided by 68,000 gives us $1. Now if we, that gives us a total $12 variable cost per unit. Now if we buy the unit for outside, it's going to cost $13.50, we're told. So this is a difference now of $1.50 per unit. The reason we are not addressing this 408,000 is because it does not vary between the two options. It's going to be the same, so we can ignore it in this particular case. So right now, it looks like if we buy, we will actually end up spending an additional $1.50 per unit. Now we've got another question here. Same information. It says, now assume that they can avoid $97,000 of the fixed costs a year by outsourcing production. So they will save some of those fixed costs. And because sales are increasing, they need now 73,000 switches a year rather than 68,000 switches. Okay, so we can kind of do a similar outline to what we did before. We can have a make or buy couple of columns, and we know from before, let me back up, that our variable cost per unit here was $12 to go ahead and manufacture in-house. So let me go ahead and write that in. If we are going to make if we're going to make 73,000 switches times $12 per unit, that means that we will incur $876,000 in variable costs. And then we add to that our fixed costs of $408. Our total cost will be $1,284,000. Okay. Now again, this $12 variable cost included our direct materials, direct labor, and manufacturing overhead. Now if we buy, we're going to incur we're still going to have to buy 73,000 units times an average cost now of $13.50. That makes $985,000 in those variable product costs. And we can avoid $97,000 of this $408,000. So that leaves us with $311,000 of fixed costs, or $1,296,500. Okay, so if this is the scenario, then it looks like we are still better to manufacture in-house rather than to outsource the switches. And the reason is because this $1,284 is less than the $1,296.5. So even though we're going to save some fixed cost, it's not enough to offset the more expensive purchase price. Okay, and there's one last part to this problem, and it asks us, given the last scenario, what is the most that TEKsystems would be willing to pay to outsource the switches? Okay, well, we already know that we won't pay more than what it's going to cost us in-house to make. So we can say that our costs, which are the variable and fixed costs to produce the switches, is $1,284,000. And the way we got that was by taking this number of units, 73,000, times $12 per unit, and then added our fixed costs. Okay, so if that is the case, then we know we will produce X, which will be the cost, times 73,000 units, because that's what we need, plus the fixed cost of $311,000. So if this is the case, we can take the 311, subtract it from the 1284, that gives us 973, just some basic algebra here, and that will be 73,000x. Probably looks better that way. So if we do the math, then that tells us that the most we would be willing to pay per switch will be $1,333.